Cassava is an important crop for African farmers. Millions of African farmers grow and depend on this crop daily for their food and for income. But it has a lot of problems in terms of length of breeding time and also some problems with diseases, a lot of diseases that have really affected the productivity of the crop and other things like yield. And so a few years ago in 2012, scientists from various backgrounds in the United States and Africa and South America combined to seek solutions to these problems, which includes things like flowering, improving flowering and seed set, and also shortening the time to breeding. We started this as a proof of concept kind of thing to discover these tools that are needed for breeding varieties that are better than what the farmers are growing. And we have been able to, within 5 years, been able to beat our targets by shortening the time and getting varieties that are ready to be deployed in farms in Africa. Currently, we have nearly 20 varieties being tested in farmers' fields in Nigeria, and in the next 1 year, we will have the same kind of number in Uganda and also in Tanzania. From this project, we've been able to see that the tools we've generated are not going to be relevant or useful to the project alone, but to the broad community of scientists who breed cassava in the different countries where cassava is important, and also to the farmers who will benefit from the varieties that were being developed. And so I think that the things we've learned includes the participatory trials where we've been gender inclusive, trying to understand the preferences of men and women, young and old, in cassava traits and in cassava varieties. And we are trying to bring the learning back to the genomic selection to improve our selection. So this, in a way, will go a long way to make people understand and see the usefulness of the tools. One other thing we've done we've been able to see in the project is a database called Cassavabase, which we have developed and is an open source plant breeding database, the first, I must say, in the world for our crop, and other crops are beginning to leverage from it, like yam, sweet potato, and bananas. So the data we have generated today is nearly 10 million data points, and is still growing. The data we've generated is open to anybody in the world who is working on cassava, and we are willing to work with and partner with anybody who wants to contribute data to it to enrich the database for better variety development in the future. We decided to make Cassavabase open source because the crop is very important to Africa and to many poor people. So to enhance and to move forward in a fast way, the development of this crop, we don't want to start bringing the impediment of storing data, of keeping data from being beneficial to farmers. So we believe that the more open this data is to scientists across the world or researchers who want to collaborate or partner, the faster we can bring better products to the farmer and be able to make cassava fulfill the role of food security and income generation in the very poor countries where it is needed.